Just to start off with the binomial expansion, and we do questions. Then we move to sequence and the series. We do another 2 questions for this session. So we start off with the binomial expansion. Do you have my screen?
Yes.
So we let us do the highlights of okay, our binomial expansion. So what are we going to learn in binomial expansion? What to note? We have to know that there is a Pascal's triangle. Pascal's triangle will give us the coefficients. Two, we must know the art of expansion. In this expansion, we do without coefficients. Then we must know how to insert the coefficients. After inserting the coefficient, then we evaluate. After evaluation, we use the expansion to evaluate numerical cases. And that marks the end of binomial expansion. Now I want us to work on one equation. So I want us to see how are we going to do we use Pascal's triangle. We apply the expansion, the art of expanding, get the coefficients, evaluate, use the question to expand numerical case. And that's all. So one typical question. In our blue books, we go to test binomial expansion is at test paper 1, test trial 1, paper 2, question 7. Try 1, paper 2, question 7. And you know, I've marked the faces and the names that are here. Immediately we get back to school on May. I would like to meet all the books that you have used to attend these sessions. I must check and see whether you did the assignment we agreed, whether you took up the notes, the short notes that we are doing, and such. So once we are back, if you are in my list, I expect to see that work. How I want to see elaborately how you did your writing, how you did your notes, all such. So test paper number 1. Okay. So mine is here. Trial 1, Paper 2, question 7. Expand and simplify the expression 4x minus y over 2 raised to 5 raised to power 5. So I'm going to seek, you are going to give me the coefficients of 5. So somebody should be checking on the coefficients of 5. Okay, now let's start. Our question says we expand 4x minus y over 2 raised to power 5. So 1, you must take note of this negative. It means the negative is going to alternate. So expansion without coefficients. We start with the first term, which is 4x, and the first term is always raised to 5, and the second term, which is y over 2, is raised to 0, minus 4x raised to 4, y over 2 raised to 1, plus 4x to power 3, y over 2 power 2. As we said, the power keeps on increasing for the second term and decreasing for the first term. And if it is negative, it keeps on alternating. 4x power 2, y over 2 power 3, plus 4x power 1, y over 2 power 4, minus 4x power 0, and the y over 2 power 0. In exam situation, we don't need this one, because anything raised to the power of 0 is always 1, and we don't need this one. Anything raised to the power of 0 is always 1. Then evaluate. So the art of expanding, this one is expansion without coefficients. Then you go ahead now to evaluate. We expand what is in brackets. So 4 raised to power 5, I think is what? Beth, you have
20.
calculators. Huh?
1024.
1024.
Mm.
Minus 4 to power x power 5 minus
Yes.
minus 4 to power 4
256.
4 to power 4 256. 256 x power 4 and y, and then over 2. Are you seeing these two here?
Yes.
Plus 4 cubed is 64. X cubed, y squared over 4 because of y squared and 2 squared minus 4 squared is 16 y cubed over 8 plus 4x, hapa kuna x squared, 4x y power 4 over 16 plus not plus, minus minus 4x. We're done with this one. Minus 4x imekuwa 0. So it is minus y power 5 over 32. Well, this is expansion without, we can evaluate further, so that we have now the final 1024 x power 5, 256 by 2, 128 x power 4y. Eh?
Mbona na multiply na 2?
A multiply na
2.
Okay, 2, we are not multiplying, we are dividing. Okay, let's get back at this stage. We have 2 terms, 4x and y over 2. Those are the 2 terms. Then we said take note of the negative. So it is the negative and the positive are going to alternate. So negative, positive. So we expand without coefficients. 4x to power 5, y over 2 power 0. 4x power 4, y over 2 power 1. That one is normal, Beth. Are we in agreement?
Yes.
Then now we come to evaluation. Evaluation, it is where we have 4 raised to the power of 5, 1024. The second term, y over 2 raised to power 0, it becomes 1, so we don't include it. Second term, 4x to power 4, 256 over 2. So this 2 is coming from y over 2. Y over 2 raised to power 1. So there is y then divided by 2. This 4 is coming from y over 2 raised to power 2. So we square the y on the numerator and we square the 2 on the denominator. That gives us what? 4. Now we in agreement.
Yes.
So that's why we have these 2, 4, 8, 16, 32. That is coming from the raising y over 2 to a certain power. Now let's proceed. Plus, get back to red. Plus, here 1 here by 4. 64 by 4, 16.
Yes.
16 x cubed y squared. Minus here 1, here 2. 2 x squared y cubed. Here 1 here 4 plus y to power 4 over 4 minus y to power 5 over 32. So this is not the end of the equation. We need to find these are now without coefficients. We need to bring in coefficients. So what are the coefficients of 5? Somebody to give us the coefficients of 5. Coefficients of 5 are 1,
5,
5,
10, 10, 5, 1.
1. So we multiply by the coefficients. Let me get back and so we multiply by the coefficients. Every time we multiply by the coefficients of these, I believe we are multiplying. So let's multiply by the coefficients. So the first term we multiply by 1. So we get then 24x
24.
power 5.
5.
The second term multiply by 5. 128 times 5.
640.
640 xy x power 4 then y plus 16 times 10 160 x power 3 y squared 2 times minus 20 x power 4 x squared y power 5 plus times 4 5 over 4 x power x square x y power 4, and then the last one times 1 minus y power 5. Yes.
Is 20x squared y to power 3 or power 5?
Power 3. Y power 3. Y power 3. Okay, let's move on. So this is the expansion that we want. This is the expansion that will earn you now the 2 marks. Now our second question says evaluate. We are using this one to evaluate. Use your expansion. Hence, use the expansion in A above to approximate the value of 39.4.6 power 5 correct to 3 significant figures. 39.6 raised to power 5. So we are using our expansion to evaluate that that 9.6 that 9.6 raised to 5, and we are using the expansion. What did we expand? We expanded for minus y over 2 raised to power 5. Here is the art of doing this thing. We must get back and check on what we relate the two. Let us relate the two. How can we express 39.6 to give us terms. And probably the one that can give us something that can be expanded easily. So for my case, I want us to express 39 as 40 minus 0.4 raised to power 5. Will this one give us that 9.5.6? 40 minus 0.4, what do you get?
39.6.
Good. So there is a way that we must reason in this binomial expansion when we are using it to solve a numerical case. We express it in a way that we can expand easily. It is easier to expand 40 than expanding 39 squared. Kutafuta ni ngumu than raised 40. It is easier to say 40 squared is 1600, but 39 squared, it gives you a little bit of thinking. So we express, we come up with two terms. For equivalency, we come up with two terms, and then the two terms are like the ones we are using to expand, but it was 4x. Silikuwa 4x. The first term was 4x. Now let's evaluate. So we equate corresponding terms. We are in agreement that we have 39.6 to be expressed as 40 minus 0.4.
Oh.
Then the first term corresponds with the first term. So our first term is 4x, which is equals to 40. Divided by 4, divided by 4. So x is equals to what?
10.
10, eh? We also equate the second term to the second term. Our second term is y over 2. Y over 2 is equals to 0.4. Cross multiply. So y is equals to 0.1, 1.6, how many? 0.8.
Yes.
0.8. Okay.
Yes.
So we have the value of x and the value of y. Now, having the value of x as having the value
10.
of y as 0.8
Oh,
and the value of x as 10.
10.
Now we get back and substitute in our expansion. What was our expansion?
1024.
1024 x power 5. We substitute in this expansion, and then we get the figure that we want. So let's substitute. I will substitute and then you launch for me the answer immediately because we have calculators. Ten 24 into 10 power 5 minus 640 into 10 power 4 and then 0.8 plus 160 into 10 cubed and 0.8 squared plus 20 into 10 squared, then 0.8 such. We substitute and then we get directly we get the answer. I'm going to give you 1 minute, then you complete. Yes, by now you are done. Mombi, what's your answer?
I came in late.
You came in late.
Yes.
Abigail, you have been here from the start. So what is your answer? Abigail, unmute yourself.
Still doing it.
Hmm?
I'm still calculating.
Abigail is still calculating. Beth, your answer? Beth, your answer. I should collect at least 2 answers from your side. I must know that we are together. Rose.
the answer nini? Cha ni kubwa.
Eti nini kubwa?
Cha unakuta 97 million.
Kwa nini unataka ikae ndogo? If that's
Cha
what you are
kunaweza
getting, let me ask you, if that's what you are getting, what is the problem? Eti ni kubwa sana.
cha yangu nimekuja 97 million 383,424.5.
Okay. Are you contented with our steps?
Yes.
Are we correct in our steps?
Yes.
That's what you should ask yourself as you are calculating. If you are contented with your steps, then you should not worry. Eti answer ni kubwa. Let me show you the answer, maybe from our. Have I shared the answer?
Yes.
Our marking scheme, Our marking scheme says what? Part A?
97,382,400.
And what is your answer?
97,383,424.
But the question was saying express your answer to 3 significant figures. So to 3 significant figures, it becomes what?
97,400,000.
So we should not be worried what we are getting. We should be consistent to the process. So the first line is expansion without coefficients. That will normally give you 1 mark, where the first term is having the highest power, and the second term the power keeps on decreasing from 0 onwards. Then this in our case, though we were not instructed, if you get back to the question, we were not very much instructed how to leave your answer. Serious?
Yes.
Yes, but now you listen. Sometimes you are told using the first 2 terms. Huyu ametumia first 3 terms. 1024 x power 5 minus 640 x power 4y plus 160 x power 3 y squared. But you can do everything if you are not told. Sometimes you are told expand up to the power x cubed, or expand up to the 4th term or 3 terms.
Yes.
Then from there we go to part B. B, we said we are using our expansion to expand that 9.6. So we express that 9.6 to have 2 terms, but we check that we must have the terms that we can easily evaluate. You know that a person can even say 39 plus 0.6 to the power of 5. Still, this thing, it is workable. But 39 squared, 39 to power 5, it can bring you troubles. So we try to make this figure in a way that it is easily multiplied, that is 40. Then we subtract 0.4. In a way, something must inform you that this number can be easily raised to a power. So we don't need this one. Then we evaluate. I hope you did see how we found x is equals to 4 and y is equals to 0.8. Then we substitute in the expansion that we have inserted the coefficients, and that's all. But now the question was saying you give your answer to 3 significant figures. This is the answer you get. To 3 significant figures, we count 1, 2, 3. We consider the next number is 8. It will add 1. So 974. So we have 97,400,000 or 97.4 million. But your answer can stop at this level, 97,400,000. Are we together?
Yes.
Yes.
Yes. Anybody want to see clarity before we attempt our final question? Mumbia, can you see your hand is up?
Cha,
Yes.
hapo juu kwa where we have come to a conclusion of putting 40 minus 0.4, reason ya kuweka 0.4.
Okay. We here there is no exact formula, but what will guide us is how can we get a number that is we can easily multiply. For example, 39 plus 0.6, it can still work. But look at expanding maybe zeros. Yeah. So we hope I'm back. Huh?
Yes.
Beth. Yes. Back to Mumbi's question. How do we conclude that we need 40 minus 0.4 and not anything else? We consider the 39.6. It is very easy to multiply 1, 10, 100, 1,000. I've seen that one, or 20,
Yeah.
or 30, 40. It is easier to square these numbers because we know zeros, they don't have much effect. So we choose a 40 because it is the next number to 39, and that 40 can be easily be raised to powers. So that's why we land at 40. But what can we do to 40 so that it gives us that 9.6? So we subtract 0.4. So we choose the numbers that can be easily expanded, can be easily multiplied. And those numbers must be having a 0 somewhere. It is either 1 or a 0 somewhere. Now, are we in agreement?
Yes.
Okay.
Yes.
Now, we can go to maybe another question. Our next equation is on binomial expansion. It is trial what? Trial 3. Trial 3, paper 2, question 11. Trial 3, paper 2, question 11. Paper 2, trial 3, question 11. Hope it is binomial. Yes. Let me share. Expand 1 plus x to power 6 up to the 4th term. Using the binomial expansion in A above, estimate the value of 1.9. 1.9 to power 6. Okay. Let us see how it will behave. Okay. So here is the. So the process is very simple as we agreed. 1, expansion without coefficients, insert the coefficients, and then use the expansion to evaluate a numerical case. So let's expand without coefficients. Our expression is 1 plus x to power 6. To expand without coefficients, we start with the first term, which is 1. 1 to power 6 is always 1. Then x to power 0 plus x to power 6, 5 is 1. Then x plus x to power 4 is still 1. Then x to power 2. Plus, we are told up to the 4th term. 1, 2, 3. 4th term is 1 to power 3, x to power 3. Hapa kuna 1 to power 4 na hapa kuna 1 to power 5. Hapa kuna 1 to power 6. So when the term is 1, we don't struggle so much. So this one gives us 1 plus x plus x squared plus x power 3. This is the expansion without coefficients that will always give you 1 mark. Then insert the coefficients. What are the coefficients of 6? 1, 6. What are the coefficients of 6?
1, 6, 15, 20, 15, 6, 1.
So we stop at 20 because we are told to expand up to the 4th term. Sawa. So we go ahead and we multiply 1 plus 6x plus 15x squared plus 20x cubed. So we are done with expanding. You get another 1 mark. But because it was so simple, this one has been awarded 1 mark. It's not involving as the first one that we did. You can bear witness. Then part B, using the binomial expansion in A above, estimate the value of 1.9 to power 6. 1.9 to power 6. Express this one to have the 2 terms. Now for this one, it is advisable that you have the first term, you compare with what we did our expansion. Our expansion is what? 1 plus
1 plus
x power 6. Then we use this one in relation to this. So when the first term does not have an unknown, you can see there is no unknown in this case. It's just 1.
yes.
No, there is no letter that is attached there. You always purpose that the first term to be the same as the first term. So it is equals to 1. What can you do to 1 so that you get 9.1.9? You add 0.9. Are we in agreement?
Yes.
Yes, we tend to check. There's a number of aspects that we should have in mind as we are doing these things. It's a skill that when the first term does not have any unknown. Remember our first term in the previous example was 4x, where 4x it had unknown. That's why we had a 40 somewhere. But in this case, the first term does not have any unknown. So we must let it to be 1. Must be 1. Then what can you do to 1 so that you get a 1.9? We are going to add 0.9. Then now we equate our first power 6 will cancel each other. 1 will cancel with another 1. 1 equals to 1, so they have cancelled. So we remain with the x. X is equal to 0.9.
9.
So with this, the x is equal to 0.9. We substitute in our final expansion. We substitute in this one. So our answer would be 1 plus 6 into 0.9 plus 15 into 0.9 squared plus 20 into 0.9 then cubed. What is the answer? Using our calculators.
$33.13.
33.13. Yes.
Yes.
Is there a condition that you are given in the question? Estimate the value of. So if there is no condition, leave your answer to 4 significant figures. You know, you are not told maybe to 3 significant figures or to 2 decimal places, but most of the questions will be guiding you. And we let this one to be our answer, 33.13. Anybody wants a question? Irene, yes, I can see your hand. Unmute yourself, Irene.
Sure.
cha marking cha kuna place cha unaona kama mali unaambiwa 1 plus x imerizwa into 6 alafu unaambiwa we estimate kwa 1.9 imerizwa to 6 cha kuna vile unaweza pata hizi raised to 6 hazifanani, pata moja iko 5 na ingine iko 4 ama hii ingine iko 5 na ingine iko 6.
Give me an example.
Cha, let's say now like here you cha, let's say like here you are told expand 1 plus 6 raised to 5 up to the 4th term. Alafu kwa B
1 plus
x raised to 5. Alafu kwa B umeambiwa using the binomial. Sasa kwa B na umeambiwa using the binomial expansion in A above estimate the value of 1.9 raised to 4. Cho unaweza pata swali ka hiyo.
1.9 raised to 4.
Hizi vitu zenye una raise hazifanani.
Probably no. We have not experienced that. That must be a typing error. The powers must be the same. Eh? Yes, must be the same. At this level, the powers will be always the same. Because it will be very chaotic if the powers are not the same. All the questions, if we go through, we are going to say like they are the same. Eh?
Yes.
Another concern?
No.
All right. Another person who has something like general you want to ask on binomial expansion. So I want you to attempt this. So you try the rest of the questions. Let us go to test paper 10, paper 2, question 5. Trial 10, paper 2, question 5. Trial 10, paper 2, question 5. Are you there?
Yes.
Now I want us to relate the two, not decide that we work out. But we are told expand 2 plus x to power 5 up to the terms x to power 3. Approximate the value of 2.03 to power 5. I want you to see that we are expanding it 2, and the first term does not have the x, does not have the unknown. So where are we supposed to work up to? So to get that is, I want you to relate the two before we even expand. So we want to have 2 plus x to power 5. That's what we have expanded. We are using this one to express, to evaluate 2.03 raised to power 5. So definitely, our first term is 2. So we must start with the 2 before we make this one to have 2 terms. we go to whatever we expanded. The first term is 2. That's when we don't have the unknown. We must start with the 2. And then we say, what can we do? Do these 2 so that we get 2.03. You add 0.03, then to power 5. This 5 will cancel with this 5. 2 will cancel with this 2. So that will remain as x is equals to 0.03. That's what we want to substitute in our expansion. Now, a shortcut, when we want to save on time, we are expanding up to which term? Up to the term x is power 3. Start by the coefficients. What are the coefficients of 5? It is 1. Then bring in the first expression. 1, 2 to power 5, and x to power 0. Plus the coefficient of 5 into 2 to power 4 and x power 1. Next coefficient is 10. Where is it 10? So we expand and then later we substitute. What is the coefficient of 5 are 1, 5, 10, 10. X power 2 plus 10 into 2 power 2 x power 3. And we are told up to the term x power 3. We stop at that level. We evaluate and then we insert we evaluate, then we substitute x as 0.03. And that's what is required. Wonderful. You try the rest, and then tomorrow we shall start by maybe what did not work out in our, whatever you encounter that is serious, you will ask. That's all for binomial expansion. I want us to take some notes on sequences and series. We attempt one example and then we call it a day. Binomial expansion. Sequences and the series. I want to go directly to what is what we are supposed to know. What we are supposed to know in sequences and series. The first thing to know is something on a general rule that is governing any sequence. And in any case, this one you will be given. you will be given this general rule. Maybe you are told in a sequence, the nth term is given by 2n plus 3. So what follows is that state the first 3 terms of the sequence. So we know that when n is equals to 1, that is the first term. When n is equals to 2, the second term. When n is equals to 3, third term. And when n is equals to 4, that is the fourth term. So we simply substitute. We substitute in we substitute value of n in the nth term. That's the last term of any given sequence. It's given by 2n plus 3. So we substitute 1. So our first term will be 2n. 2 into 1 plus 3, which gives us 5. 2 into 2 plus 3, it gives us 7. 2 into 3 plus 3, it gives us 9. 2 into 4 plus 3, it gives us 11. So the first term of this sequence would be 5, 7, 9, and 11. These are the first 4 terms of the sequence. So we should know how to get the terms when we are given the general rule that is governing a certain sequence. So that's the first aspect. General rule that is governing the given sequence. So that's the first thing that we are supposed to know. And we shall be given the nth term. And from the nth term, then we are told you write down the first 4 terms of the sequence. So we get the first term when n is equals to 1, when n is equals to 2, when n is equals to 3, when n is equals to 4. We substitute in the nth formula. So 2 into 1 plus 3, 5. 2 into 2 plus, where these are the values of n. Well, and then from here, other questions will follow, as we are going to see. Another aspect, so that's one. Another aspect that we should know, so tumesema the nth term, when you are given the nth term, we are done with that. Number 2, in sequences and the series, we have said the first one, it is when you are given the nth term of a sequence. Number 2, we have now 2, categorically we deal with the 2 sequences. The first sequence is arithmetic sequence. Which we are going to, most of the time, we are going to refer it as AP, arithmetic progression. In this arithmetic sequence, we are supposed to know 2 things. The first thing, it is nth term, which is always equals to a plus n minus 1 d, where a is the first term, n is the number of terms, and d is the common difference. We should know the sum of any terms of the sequence, which has 2 formulae. The first one is n over 2 into 2a plus n minus 1 d, and that's all. Or it is n over 2 into a plus l, where l is the last term. The beauty of this thing, it is there in our mathematical tables. Then we have number 3, geometric sequence, commonly called as GP, geometric progression. Here we also know two things. It is the nth term. How do you find the nth term? A, R, n minus 1. How do you find the sum of first n terms of the sequence? There are two formula. A into R power n minus 1, then over R minus 1. This is when R, the magnitude of R, is greater than 1. We have another formula for the sum of n terms of the sequence, which is A into 1 minus R power n over 1 minus R. This is when the magnitude of R is less than 1. So you grasp the two. And then finally, what we need to know is applications. You read a question, and from that real life, that's really given a situation, then you are the one who will determine whether it is aligning to the geometric sequence or it is aligning to the arithmetic sequence. So all of these ones must be known. You have to, you are a candidate, you have to master these short stories about geometric sequence, about arithmetic sequence. So we have only 5 aspects. The first one is nth term. How can you behave from there? The second one is AP. How do you find the nth term in arithmetic progression? How do you find the sum of n terms in arithmetic progression? The third one is geometric sequence. How do you find the nth term in geometric sequence? How do you find the sum of n terms in a geometric sequence? Once you grasp those ideas, then now you can move to addressing a question. Any concern there? Anything you want to seek clarity? Susan, are we together? Susan, yesterday you were unable to mute. Today, unmute and talk to us. Susan?
Yes.
Tusalimie.
Good morning.
Hi.
Good morning, Susan.
I'm
You
just
come
doing
from
the
which class?
lesson. No, I'm
You have
Gloria.
chatted. You are Gloria.
Yes.
Oh, you gave us a different name. We know you as Gloria, not Susan. Susan is nifikiria Susan kwa hiyo klasi si kuiona Susan. Well,
Yes, my name is Gloria.
all right.
I'm just doing the lesson.
Right now.
Yes.
But you started, you are the 10th one. You started with the geometric. You started with the sequence and the series, sindio?
No.
Umeingia tu sahi?
Yes.
Ujaona tukiandika hii mambo yote?
No, there was some inconvenience.
Umeingia at tukiandika nth term. Well. Abigail, are we together?
Yeah.
Now, I want us to go to sequence and the series to our blue books. We attempt one question. Sequences and the series. Kwani sioni? Iko hapo, mumeiona? Sequences and the series. Trial 3, paper 1, question 12. Trial 8, paper 1, question 24. Hebu tufanye hii ya 10 marks. Hope ni sequence. Trial 8, paper 1, question 24. Tumesema trial 8, paper 1, question 24. Yeah. It is under sequence. Sawa. An arithmetic progression. Hebu mtu atusomee hiyo. Rose, read for us that question.
An arithmetic progression, AP, has the first terms, A, and the common difference, D. Write down the third, 9th, and 25th terms of the AP in terms of A and D.
Continue.
B. The AP above is increasing, and the third, 9th, and 25th term from the first 3 consecutive terms of the geometric progression. The sum of the 7th and twice the 6th term of the AP is 78. Calculate the first term and the common difference of the AP, the sum of the first 9 terms of the AP, the difference between the 4th and the 7th term of an increasing AP.
Well, this question is it is mixing both. It's mixing the geometric and arithmetic. But we need to analyze the question properly as we tend to decode, as we tend to bring in the ideas that we know. So you read and you try to bring in the ideas. An arithmetic progression has the first term, A, and a common difference, D. Write down the third. So we start with the third. In the third, we know that n will be equals to 3. So the nth term in arithmetic is progression is A plus n minus 1 D. So we substitute in the nth term. So our first term is A plus n minus 1, 3 minus 1, 2. So 2D. That is the third term. And then we write the ninth term. Ninth. ninth term, n is equals to 9. Substituting in the nth term of arithmetic sequence, it is a plus n minus 1, 9 minus 1, 8d. 25th term, 25th term, n is equals to 25. So a plus, that is a plus n minus 1, and n minus 1, 25 minus 1, 24d. You have the three terms. Are we together? All right. So we are done with part A, and we have 1 mark. Now you must build the question from that end. Try to bring in what you know. So the first, third term, 90th term, 25th term, such. B, the AP above is increasing, and the third, 9th, 25th terms form the first 3 consecutive terms of geometric progression. So this thing will change to now GP. A GP that we are told the third, which is A plus 2D, form the first term. 9th, which is A plus 8D, form another term. And 25th, which is A plus 24D. They form 3 consecutive terms of geometric progression. What do you know about 3 consecutive terms of geometric progression? They give us common ratio, R, where common ratio is equals to A plus 8D over A plus 2D. We said somewhere that if we have 3 consecutive terms, common ratio would be the second term over the first, which is equals to the third term over the second. So A plus 24D over A plus 8D. This expression is making sense because it makes the first, it makes consecutive terms of a geometric progression. So we are supposed to get the common ratio from there. So we have this statement, and of course we know where it is coming from. Sindio?
Yes.
Now I want you to cross multiply. Cross multiply to see which extent it can go. Where will it take us? Let's cross multiply. So let's cross multiply 8 A plus 8D, A plus 8D is equals to A plus 2D, A plus 24D. So A times A squared plus 8AD plus 8AD plus 64 d squared, si ndio?
Yes.
It is equals to a times a squared plus 24ad plus 2ad plus 48d squared. Let's have the corresponding terms together. Corresponding terms together. A and A will cancel, sindio?
Yes.
This one gives us 16AD. Sawa.
Mm.
Okay, 16AD. This one plus this one gives us 26AD. Sini kweli? So we have 16 AD plus 64D squared is equals to 26 AD plus 48 D squared. Like terms together. Tuchukue gani wapi? We take this one to the other side.
48.
To the other side, 26 AD minus 16 AD, 10 AD, si ndio? Tuleta hii hapa.
Yes.
48 to this side, 48 minus 64 minus 48.
16.
16D squared. 1D will cancel 1D. So we remain with 10A. This equals to 16D. Divided by 10. So A will be equals to 16 over 10D. Are we in agreement?
Yes.
We cannot move any further. That's the extent we can go. Sawa. So somewhere we have A is equals to
Sixteen over
we have A is equals to 16 over 10 D. Sawa. Let's get back to the question because we cannot move now further. In the confused writings of mine, we are told also that the sum of the seventh and twice the sixth terms of the AP is 78. Sum of seventh. So 70 term inakaaje? 70 term, it is A plus 6D. Si kweli?
Yes.
The sum of the seventh and twice the sixth term. Sixth term, it will be A plus
5D.
5D. But we are told twice, the sum of seventh and twice the sixth term is equals to 78. So A plus 6D plus twice the sixth term, 2A plus 10D is equals to 78. The sum of the seventh and twice the sixth will give us 78. A and A, 2A, 3A, 6D, plus this one plus 16D. This equals to 78. Sawa. Now, so far we have two equations. One equation is A is equals to 16 over 10D. Another one is 3A plus 16D equals to 78. So let's substitute. Substitute in the two. Iko mtu tumeaja. Beth Wanja, your hand is up.
Cha.
Yes.
Cha unaona place wanasema twice the 6 terms. Cha now there. Cha, are we not supposed to like cha we do A plus 5D, we multiply by itself like we do the square.
Okay. Let us read the statement. The sum of the seventh term, we can know exactly what it is. It is A plus 6D. Sini kweli?
Yes.
And twice, twice is like you double what you have. Twice the sixth. So we are not squaring, we are multiplying the sixth term by 2. You get that one, eh?
Yeah.
It is twice. So we multiply the sixth term by 2. That's why we have this one. We have the sixth term as A plus 5D. But twice of it will be A plus 5D times 2. So that we get 2A and then 10D. That's our.
Yes.
And that's what we have substituted. Allow me to erase a few so that we make our working a bit less chaotic. Well, we have these two. From the first condition, where we are told that it forms the 3 consecutive terms of a GP, we worked out until we add something. We add A is equals to 16 over 10D. Naona hiyo? Hapo tulipata. And from where we are told that the sum of the 7th and twice the 6th term is 78. We have this, we have 3A plus 16D is equals to 78. So we have two equations. Now substitute A, the value of A in this expression. So we have 3A. But what is A? 1.6D. It is equals to plus 16D is equals to what? 78. So 1.6 it is times 3 is 4.8D plus 16D is equals to 78. This and this one gives us 20.8D is equals to 78. Divide. D is equals to what? 78 divided by 20.8D. Okay, a decimal.
7.5.
7?
5.
7.5.
3.75.
Good. 3.75. That's the value of D. Sindio? So we want A. A, we get back and substitute. So A is equals to 1.6 times 3.75. What do you get? Tunakuja hapa tuna substitute. Kwa D tunaweka 3.75. So 16 over 10 times 3.75. What do you get?
5.35.
Yeah, 5.35. Well, what was the question? Roman 1, the first term and the common difference. So what is the first term now? The value of A, 5.35, eh? And the value
So
of D. Where? Kuna yule ali multiply 1.6 times 3.75. Eh?
Yeah, 6.
It is 6.
Yeah.
What is 1.6 times 3.75?
Shall we multiply?
Yes.
It's
6.
mm.
The one who gave us the other one, hope you have seen. Tunasema A, it is equals to 1.6 times 3.75. What do you get? We get 6.
Yes.
Yes.
Okay. So our first term is 6. Our common difference is 3.75. Yes. Are we together?
Yes.
Anybody who's not with us, then we can do something. Now I want you to take the 5 minutes. You finish Roman 2 and 3.
Um,
Yes, are you done? Memaliza? Okay. The sixth term, the first term and the common difference. Rose, first term ilikuwa gani? What was the value of A? Hmm? Rose, are you here? Ni Rose. Rose yako. Well, now it is time to talk.